Subrat in particular, and to you as well for the invitation for this session. Really excited to be presenting before you all today. And yeah, with that, let me share my screen and we can get started. Yeah, so hope the screen is visible. If not, let me know. Yeah, so today's talk is about large language models and a few more details about the LangChain library in particular. And so we'll start. So here's the overall flow. We'll start with giving a brief background on large language models, how they work, and how they came into being, how they are being trained, what all functionalities they offer, and then we'll see an introduction about this library in particular, LangChain, which provides tools on making best use of these large language models and how you can build complex workflows or applications on top of these LLMs. And yeah, so that would be the overall flow. We'll cover two main aspects of LangChain library, which are basically chains and agents. And we'll delve into those in more detail once we get to the library. So yeah, the first part is what is driving these models themselves. So what is the driving force behind LangChain, which are the large language models themselves? So yeah, unless you have been living in a far-off cave, you would obviously have heard of ChatGPT or these variety of language models that have been popping up. And I'm very sure that most of you would have used ChatGPT in one or other of your tasks. So be it to generate some code side by side as an assistance, or maybe for help with your assignment itself, or to find solutions to any of the questions that you might have about a new topic. So you all would have seen the amazing abilities it has, be it in a variety of domains. And so ChatGPT is just one such very good example of what we call a large language model. Uh, uh, and these have, so language models have been around in the natural language processing community for a while now. But the ability that we see today, that they are able to generate amazing content, or they are able to act as chatbots, or the improvement even in the translate quality that we saw maybe a few years back versus what we see now. So all of these has been made possible mainly due to two aspects. One, the data set size that these models were being trained on, that grew quite large from in a very small time. And second is the model size itself also grew large. And and all of these models, they, by virtue of how they are being trained, they have this ability of being able to understand and respond to any natural language instruction that has been given to it. And so we see a lot of applications also popping up, which makes use of this ability of language models, and they build some utility app or any application around it. So yeah, we have seen it being able to answer questions based on any given data. So something we call closed domain question answering. And these models are getting quite good at closed as well as open domain question answering. And also something which we observed in multiple of our projects where we are making use of these LLMs is that they are quite good at summarizing a lot of data, which could take a lot of tedious manual effort from the part of any human annotator. So a lot of companies are also utilizing this as a way to summarize a large body of text that they have, and which is something also what we are doing in a few of our projects. And the reason for this talk again is also that we would like to share some of the insights that we have gained while working on these LLMs in actual live projects. So yeah, some few of the questions that people have about these models is, should we attempt to train or host our own language models, or should we use the ones that are directly available? So short answer is, unless you expect the application that you're building to be in a very specific niche area where these large language models or generally available models are not able to work well, then maybe you could think of training or fine tuning your own version. But otherwise, it is mostly overkill to attempt to train your own. And second could be, if you have a use case where you expect a lot of traffic and lots of users to attempting to use these models, then again you could host your own inference service. But again, it would be for a much smaller scale models than the publicly available APIs, which mainly currently are, one is the ChatGPT API by OpenAI and other is Palm by Google. There are other services also coming up in the recent years. So there's another company called Anthropic, which also provides APIs to LLMs. But mostly we would suggest using those hosted APIs rather than trying to build your own. And so yeah, how do these models have these amazing abilities? How are they trained, and how did they progress so far? So this is a very brief overview. So this in itself could be maybe a long lecture or even a series of lectures on how the language models progress. But to give a very brief overview, we had started with something called of a sequential architecture, which was called LSTMs, and the models back then used to have in the order of millions of parameters, and they also had some good ability to mimic the text or the writing style of any particular author, but none of the abilities that we see now. So the size of the models grew from being a million parameters to hundreds of billions parameters, which we see today. The data set size on which these models were trained, they also grew from a smaller size to over 1 trillion tokens today. And the core idea, which I particularly find quite interesting, and so how do we train these models to be able to understand the language? So there are a lot many rules. There are lots of connections between words. How do we get these models to learn these tasks? So there are three particular techniques there which gained popularity. One was just having the model predict the next token. So in NLP terminology, token, you can think of it as roughly equivalent to a word. Again, there are multiple interpretations, and I'm simplifying the idea a bit, but you can think of the model trying to just predict the next word that should occur in a sequence. So that was the first idea that any of the language models started training with. But recently, a more popular version of this is something called masked language modeling task. So where we essentially mask out few of the words within any given text, and the task of the model is that it tries to predict what words should appear in place of those masks. And as humans as well, so if anyone is able to intuitively figure out the blanks in a given sentence, then essentially they would have grasped the overall idea of the language, and that if they are able to do it across a variety of sentences, then they probably have learned the nuances of the language. So that's how this uh, so seemingly simple idea came into being. And then there is something called next sentence prediction as well. So again, many of these objectives were tried out iteratively, and most of the current models, they use this masked language modeling task to train the model. And we went from fine tuning. So basically, previously, when the model sizes were small, every time we wanted the model to learn a new task, say we wanted it to translate from English to French, or we wanted it to predict the sentiment of a sentence. So each time the models used to be fine tuned or trained again for that particular task. And now with the larger models, the ability grew better. So instead of fine tuning, we just need to give the model a few examples of what the task looked like, and it was able to generalize from those few examples. And then the models went a step ahead. So you just give it one example of this is how you answer to a given question, and it learns the pattern and is able to answer based on that example. And now with the ChatGPT and the larger models, we even have zero-shot ability for most of the general tasks. So as long as you just give it a clear instruction of what it is supposed to do, the models are able to perform that task almost with zero examples. So that by itself is an amazing ability that we see in the models today. And yeah, with this, so this is again an important concept about the language models. So as we saw these language models, they try to learn the semantic structure and meanings of the words as well, and overall the rules of the language as well when they are trying to generate text. So for that, how do we present the information that we have as text to the models, and how do they internally represent that information? So that's something we are presenting in this slide. So there is a concept called embeddings. So essentially, we want to represent either a single word or entire sentences in numerical form. The main reason being we want to somehow present all of this textual information in a meaningful way to any model, machine learning model, which essentially would be running on a computing system. And so, how do we represent these words in a meaningful numerical form? So that's where embeddings come in. And embeddings essentially try to so you can think of this representation as a vector space in which each point is a vector, each point represents a word. And so essentially, so we know in text quite easily that man is to woman is, say, king is to queen, or uncle is to aunt. So we know those rules quite easily or intuitively in English language. So we try to represent these same rules into this vector space. And what we observed was just a virtue of how these models were trained. So we saw that they are trained for next sentence prediction or next token prediction or just mass language modeling. And what we observed was in the representations that these models generate for the words, these relationships are captured quite intuitively. So the distance between a vector for representing the word man and representing the word woman, that distance vector was very similar to the distance vector between the vector representing king versus queen. And so this property could be useful in a number of different applications, one of which we'll also see later on. But yeah, so this embedding, so a representation of words into numerical vectors is an important concept. Yeah, so we'll cover that. And with that, we arrive at our main topic here on why LangChain in particular. Yeah, so yeah, we'll keep on checking the chat as well. So if anyone has questions at any point, feel free to drop a note there. So again, coming back to LangChain, so we saw that these language models by themselves have such amazing abilities. So what if we want to build something on top of it? So that's where LangChain comes into picture. It provides a wrapper around the APIs for the language models themselves, but not just limited to that. So we can any workflow or even a complex workflow involving decisions that you want to build around these language models, that can be done easily using LangChain. Again, we'll see ample of examples there as we move through the session. Another great thing about LangChain is it provides a lot of tools which you can connect to these language models. So, say giving the ability of to this language model to be able to search the internet to come up with an answer, or giving the ability to do some calculations using a calculator, or being able to run some code and see the output before giving answer to a particular data analysis question. So the LangChain essentially provides tools which can be connected to these language models that it can harness, and you can build applications on top of it. And for many simpler workflows, it also provides a ready-made setup. Again, something called agents, which we'll see in detail later in the session. And so with this, the the language models that we saw so far, they get some more added advantages of these tools, and so we can build great products around it. And we'll also see some examples of where people have used it and how we can utilize this to build our own applications. And so, yeah, the main part of this LangChain is the input or prompt that we provide to these models, and that's something Jeet will cover next.
Okay, thank you. All right. I hope I'm audible. So now you might have definitely seen those YouTube ads where they say that the hottest job role right now is prompt engineering. The salary, average salary is 3-4 crores. I have seen it in India. I'm not sure about Singapore if they have the same as or not. But we have definitely seen those. And while some of them are quite annoying, the claims they make about the importance of prompt engineering is pretty relevant, and we do agree with that. Why is that? Because we have seen that no matter how large the model is, the clarity of your prompt and the structure of your prompt, how well you define your prompt, definitely affects the performance, definitely affects the outputs you can get out of this LLMs, right? And that is why Andesh Karpathy rightly said the hottest new programming language right now is English, right? So we all know we have interacted with ChatGPT, most of us might have, and basically what we write to ChatGPT, the instruction that do this for me, do that for me, are basically the prompts, right? And apart from instructions, it can also uh, convey information about how do you want the output to be, the formatting, the style. It could also include relevant context that could be used. Like, for example, you might have done those reading comprehension tasks where there's a paragraph and you want to answer from that, right? So paragraph also becomes part of the prompt. Here we have a simple prompt where we are telling the LLM that to act as a computer science professor and then answer the programming question. Question here being what are for loops in Python, right? And let me read out the response. So the response goes like, hello, as a computer science professor, I'd be happy to explain for loops in Python. In Python, a for loop is a control flow statement used to iterate over a sequence of elements. It allows you to repeat a block of code for each item in the sequence until all the elements have been processed. I won't go through the whole response, but what you would notice first is the style, and it's very formal. It is something you would really hear in a classroom environment, right? But now, let's say what if you want it to be a little bit more, let's say, humorous. We want it to pop up a bit. We could just the first line that instead of a computer science professor, now we are a pirate from Caribbean, and you wanted to answer the questions in pirate English with a hint of annoyance and sarcasm, right? And the question is the same. It's the programming question that says what are for loops in Python, but the answer itself, the style of the answer itself has completely changed, and it goes something like, "Hey, Yelan Baba, you'll be asking about that fancy Python loops, I." Well, a for loop in Python be a way to make your code do something, and it's pretty hard to read. But basically, you do see that prompts are not just for getting the task done; they are also about how do you want it to do the task, right? So this was just a small example of a prompt, right? Now let's come to the main thing, the prompt engineering part, right? How do you write better prompts? So there are a lot of techniques out there, but what we are going to cover are the two of the most used ones, as well as some general tips. The first one being you need to have clarity on the objective. The objective being what you want out of the LLM. If you don't know what exactly you want out of the LLM, it's really hard to get it out of the LLM, right? So, for example, do you want the response to be humorous? Do you want it to be in a particular format, right? Do you want it to exclude something that would generally be included in the output, right? All those things you need to have clarity on, and then writing prompt is, and then starting to write the prompt is a much better idea. And generally, getting your prompts better will be an iterative process, just like you do with your models, where you train a model, you test it, it does not work as you think, you improve it, and then you test it again, right? Same way, prompt engineering would be an iterative process where you write a prompt, try to test it, and then if it does not do something that you want it to do, you improve it, right? Now, one of the most used and popular techniques is few shot prompting, right? A few shot, I guess, as Palak mentioned, is when you provide some examples, right? And here we provide examples for two objectives. One is to improve reliability of the LLMs, right? When it has some examples, uh, even when your instructions are a little bit ambiguous, those examples might provide the clarity required to the LLM, right? And second, sometimes it's just hard to convey the information, right? For example, so I don't have an example right now, but if you want to convey something, but you are having difficulty in wording it correctly, you can expect LLM to just learn it from some examples, right? So that is why a few short prompting has become very popular. Let's quickly look at an example. So what you see on the screen on the red is a zero shot example where you don't have any examples basically. And what you are just saying, what you're just telling LLM is to classify the text into positive, neutral, or negative, basically your sentiment analysis task. And then you give it a text saying that short selection was awesome, right? And LLM generates a response that this sentence seems to be positive, right? You could do the same thing but without giving any kind of instructions, right? So in the green one, what you would notice is there are three examples, uh, the text and the classification, and then your final question that shot was awesome, you need to classify that. There is no instruction in the prompt, right? Even then, the LLM is able to generate the correct response. Not only that, it was able to generate the correct format of the response. That is, I wanted a short form of the word positive, not the full word, as well as I wanted the first letter to be capital, right? I did not mention any of this in the instructions part. I just gave the examples and it was able to extract that, right? And that is your few shot prompting. Generally, you have 2 to 3 examples. In some cases, you do go up to 8 or maybe even 10, but generally it's a very small number of examples that you use for few shot prompting. All right. And the second technique is chain of thought prompting. So generally what happens with LLMs is when you try to give them a complex task, they do tend to make mistakes. For example, the one in the red over here, it's a simple question to us, right? That I went to the market and bought 10 apples. I gave 2 apples to the neighbor, to the repairman. I then went and bought 5 more apples and ate one, right? And it's a very simple chronological order of events, and we can decipher it and figure out that how many apples do I have now? It's 10 apples, but the LLM fails over here. So it's not that LLM does not have the capability to correctly answer this question. If you give it some space to reason out its answer, right, to have a chain of logical steps and then answer, it will be able to answer correctly. And how do we do that? By simply appending a line at the end of the original prompt, and that phrase or that line is basically let's think step by step, right? And what you see in the response now is LLM generate a longer response where it actually wrote down the whole process of deriving the answer, right? That first you start with 10 apples, you give away to the neighbor, to the repairman, so you have 6 apples. Then you bought 5 more, so you have 11 apples. And then finally you ate 1 apple, so you have 10 apples, right? So if you have that, there is a verification happening, validation happening, and it tends to go to the correct answer more often, right? Now the phrase "let's think step by step" does not need to be the case all the time. That's just the phrase that was given in the beginning. But depending on your task, you try out different phrases. Not only that, you could actually give it the steps yourself. You could list out that first you need to do this, then you need to do this, then you need to do this, and then you need to derive the final answers. You can list out the steps, and it's not guaranteed that LLM will follow it, but it will definitely improve the chances of it following the correct procedure and getting to the correct answer, right? And another way of doing COT is combining it with few shot prompting, where you don't really give the steps. Well, you can give it if you want, but you also give it some examples. And in those examples, you again don't give the direct answers. You also give the reasoning and then you give the answers. And LLM is supposed to learn from those few short examples that how should I do my reasoning, right? And then how should I extract the answer from the reasoning, right? And that's your chain of thought prompting. Now there are other examples, tree of thought prompting, graph prompting that has come up recently, and the landscape keeps changing. So there's a lot, but these are the most used ones, right? And apart from this, there are a couple of thumb rules. For example, sometimes when you have said something to the LLM and it is not following it, right? Where you have given a boundary condition or a constraint, right? It is not following it, then what you could try is writing it in capital letters. And that for some LLMs that tend to enforce the constraint more like in a stronger manner, so they tend to follow it more often. It's a thumb rule, so not guaranteed to work always, but that is definitely something to try. And one more thing is to keep in mind that these LLMs are sensitive to minor changes in prompt. Very sensitive in some case, in some LLMs, right? So either you avoid such LLMs or be very careful with the prompts. For example, the weirdest one I have seen so far is basically I had the same prompt, the exact same prompt. There was a blank line, and in one of the cases, the blank line was like completely blank, and in the other case, the blank line had a few spaces, which if you see on the screen, you wouldn't even be able to see the spaces, right? In that case, the LLM generated different response. Not only different, it generated opposite response, incorrect response, right? So it is very sensitive. Some LLMs are, some are not. Like that tends to change from LLM to LLM, but you need to be very careful with that. Okay. Now, what you have most likely interacted with on internet is a chat workflow with these LLMs, ChatGPT being one, of course. And there are a couple of things to note when you're trying to develop a chat workflow, right? Apart from like these prompts, they are categorized in three different types. First is your system prompt, where basically it's like a general guideline to LLM to always follow. For example, giving it a personality or general guidelines, as in you are not supposed to use curse words, you are supposed to be polite. Those kind of general guidelines are written as system prompts. ChatGPT did not have it before, but now they do give you an option to edit the default system prompt to your liking, right? Then, of course, there's the human message. That's the one that you send in to the LLM, right? Basically, do this, do that. And then, of course, there's the response from the LLM. It's basically LLM prompting us for the next step, right? And basically, that's the output, right? On the code block, you could see how to do that with LangChain. So LangChain has this template classes for different kind of prompts, and you use this template class to make your prompts. And finally, like once you have made a system prompt, a human prompt, you combine it into a chat prompt. Basically, it's a combination, and then you send it to an LLM farm over here, and it generates a response that we see in the code, right? So that is how generally chat workflow has different kind of prompts. And the another thing to take care of with chat workflow is memories, right? So when a human conversation happens, we implicitly do this. We extract context from history, right? So if, let's say we are talking about some subject, right? We do not keep repeating the subject every time we talk about it, right? Once we talked about it, we keep on talking about that subject without mentioning it. But from our history, we know what we are talking about, right? And we answer, or we tailor our answers to that subject. And for LLM to do that, it also needs to have a memory where it can hold the conversation that happened between the LLM and the user, right? And basically, it's just that, and it's a storage, right? And it's generally very useful in chat applications. In other applications, memory may or may not be required depending on what you're trying to do. But with chat applications, it's necessary kind of thing. Now, LangChain offers multiple types of memories, and we'll see why, right? So, most standalone memory is your conversation buffer memory. Basically, it stores everything as it happened, all the user messages and all the LLM responses, right? But there is also a conversation buffer window memory. So now what happens is this LLMs have context limits, right? So you might have heard when Claude came out, it has 100K context limit, and everyone was very surprised. Why? Because 100K is a lot. The ChatGPT one and the ones that initially came out had very small context limit. There's like 4,000 tokens. And when you ask LLM anything, you pass the memory along with it, right? And when you're passing the memory along with it, that also counts in that 4,000 token limit, which means as the conversation gets longer and longer, it will cross that limit. So how do you get past it? How do you bypass that limitation? Is using this different kind of memory. So one of the offering is conversation buffer window memory, right? So basically, instead of passing in the whole conversation history, you just passed last few interactions, right? And that generally tends to be true for human conversation as well, right? When we are having conversation, generally the context comes from our recent exchanges than the ones happened earlier, right? If you don't want to do that, if you don't want to have that assumption that the context will always come from the recent memory, what you could do is use a summary memory, conversation summary memory, where it summarizes the whole conversation, right? In the amount of tokens that you have asked it to summarize into, and that summary is passed when you then prompt, right? And then that summary gets on updated as the conversation goes along. But the idea is the length of the summary remains same. So again, you do not cross over the token limitation. And here LangChain has again multiple kind of summarizations for you. For example, sometimes it's important to remember the general context of the conversation, and sometimes it's important to remember the details. What date something happened on, or what was this number, what was this name, right? So that what kind of summarization you want to do depends, right, on what kind of conversation you are having. And LangChain again has multiple offerings for you. And this summarization is also performed using another LLM. All right. How to implement it? Again, just like everything we have seen in the past, you have a abstraction class for you. It's very object oriented, everything. And you basically make a class, and then when you do memory.save context, you basically give it the messages. Right now, we have just two messages, but you can keep on calling memory.save context, and it will keep on appending the messages. If it's a summary memory, it will also keep on summarizing in the background. And when you actually use that memory, that summary is sent off to the LLM, right? As I said, summary memory uses an LLM to summarize. So that's why you have to initialize with it with an LLM. Okay, now that we have our individual modules, what we are going to talk about is chains, which is why LangChain is named LangChain, right? A quick analogy to understand chains even before we get into the nitty-gritties is functions in Python. So what functions help you do is create nice blocks of multiple questions. Oh yeah, we could take any questions if you have right now before we move on to chains. Do we have nothing in the chat, right? Anybody wants to ask a question? I guess.
You can continue. I don't think anyone has any question now.
Okay. All right. So continuing with chains, it's basically how Python functions are. It helps you put everything into a nice block that could be reused and then cascade with other blocks, right? And that is what chains do over here. They combine the LLM, memory, and prompts, as well as the parsers. We'll talk about parsers later, but combine them into a nice block that can be reused, right? And as I said, you could combine one block with another block as well, one chain with another chain as well. Apart from this, LangChain also offers some ready-made chains available. Think of that as a library of functions that you generally import and use, right? So what this ready-made chain does is the use case based, right? So let's say you want to create a summarization bot. Now you don't need to start from scratch. You could just pick up this LangChain ready-made chain, customize it a little bit according to your use case, and directly start on using it, right? So there are a lot of ready-made chains available for your common tasks, and you could use that directly. Okay, now to understand chains, we are going to try building a simple product called Simple Marketing Assistant, right? Simple because it's not a very detailed, like a real life marketing assistant. It's going to be a very simple example just to understand the concept of chains, right? What the Simple Marketing Assistant does is takes in a product description and a company name, right? And spits out a product name and a tagline to market the product with. So this is supposed to help the marketing department to for in the creative aspects, right? For example, here you see that the product description goes like the perfect headphones for young music lovers with their sleek design and powerful sound. These headphones are sure to turn heads wherever you go, blah blah blah. And the company name is called Audio Mechanics, right? What our tool or marketing assistant is supposed to do is generate a product name, something like Audio Mechanics M1000 over-ear headphones, and generate a tagline to market it with. Audio Mechanics M1000 over-ear headphones turn your world into a personal concert, right? Now let's start building it. So as you see, we are trying to achieve two things, right? So let's divide and conquer. First, we want to generate a product name, and second, we want to generate a tagline. Now, one thing to notice over here is the product name is also used in the tagline generator as an input. That is because we want the product name and the tagline to align, right? Otherwise, it would be a marketing disaster. So, your name generator will have product description and company as the input, and it will generate a product name. And that product name, along with the original inputs, will be used by tagline generator that will generate the tagline, right? So now let's try to build the name generator. So basically, the way we saw so far will basically have a prompt template. Now, templates we have not talked about detail, but templates you could think of as f strings in Python, right? Basically, you have some variable placeholders that you fill in. So we'll create a template like that. And the template here looks like what is a good product name for a product with the description so and made by the company so, right? And the so placeholders will be filled in when we have the input, right? So we have two inputs, product description and company. Once we generate a prompt with this prompt template and the inputs, that goes into the model, the LLM model. Google's farm over here, but it could be anything else, right? And that model then spits out your product name according to the prompt given to it. That is how sub modules of the name generator would look. And once we have this decided, what we'll do is we'll create a chain out of it. Basically, combine everything into a nice little module, right? And we'll call it as a name generator chain, maybe, right? It does nothing, but it just combines everything. And once we have the name generator chain, we'll also create a tagline generator chain. What difference you would notice from the previous slide is now we have one more input called product name, and the template itself has changed. Of course, because we are trying to do a different thing with LLMs over here, and that is that you are a copywriter that writes taglines for customer in their teams. What is a good tagline for a product, right? And of course, you give it the product name, description, and the company name in the prompt, and it passes on to LLM, and that generates the tagline. Once we have our two modules ready, right? So okay, before we go further, let's just discuss the general diagram of LLM chain. So this is how it would look. It would have multiple inputs. It will only have one output. That is how LangChain has designed it. You will have a prompt template. You will have an LLM, and optionally you could have an output parser. Output parser is basically string parsers. Let's say your LLM is supposed to generate output in JSON format, right? It will still generate a string, but it will be a JSON string. So you want to parse the output and then pass it off. So in that case, you would use a output pass. And this is the most basic chain, right? Now, once you have this two subchains ready, the code for the LLM chain as well. Basically, you create a class LLM chain. You initialize with LLM prompt, and once you have the chain ready, you run it with your inputs, company name and product description over here, and you have your output. Okay, now finally, once you have your individual modules ready, you want to combine them. Here we are combining them sequentially because, as I said before, the output of the name generator goes into the tagline generator, right? So basically, it's a sequential operation, and that is where you use sequential chain offered by LangChain, right? This is how a general structure of a sequential chain would look. When you have multiple inputs, you have multiple outputs, you have multiple sub chains arranged in a sequence, right? And the output of the one chain goes into the next chain along with the inputs of that chain, right? So all the variables that are passed on to the next step. And you also have a global shared memory along all the subchains, right? Where it stores stuff. And it's optional. You could think of it as basically a chain of chains, right? And how would you implement it? Again, you have a sequential, you will create a sequential chain object. Here you will basically pass your subchains in the order that they are supposed to be executed. So name generator chain and then the tagline generator chain. And you have to specify the input variables and the final output variables. Once you have done that, you can execute the chain and it will generate the output, the product name and the tagline, as you can see at the end of the coded part. One of the things that you could do is you could also get to return the intermediate outputs that are not part of the final outputs physically. If you set the return on the outputs to false, it could help you debug stuff, right? All right. Now, at this point, our basic product is ready, right? But one thing you would have noticed is in the prompt for the tagline generator, I specifically mentioned that you are supposed to write a tagline for the teenage demographic, right? Which is not general, right? Let's say my product did not cater to teenage demographic, it catered to middle-aged demographic. In that case, my prompt for that tagline generator would be a little different. I would want it to generate a tagline catering to that demographic, right? So what you see is based on what kind of product it is, the tagline generator prompt has to be dynamically changed, right? The way to do that would be a multi-prompt chain in Python. Again, to analogy a programming structure, you could think of it as a switch case structure where you first evaluate a switch case, and whatever case it falls into, you execute the code in that case, right? Here, it's something similar. First, you have a router chain. The router chain decides where to route or basically which case to decide on. And then based on that, you have a sub-chain defined for each of the cases. So for teens, you have a different chain that has a prompt catered for teenage audience, and then middle-aged chain where the prompt is again catered to generate a tagline for the middle-aged audience. And of course, just like switch case, you also have a default chain. That is when router chain is not able to decide whether to use teens or middle-aged, it will fall onto the default chain, right? So again, our inputs are company, product name, product description, and it will go into the router chain, and router chain will decide based on the product description and the name what kind of audience this product is for, and then it will execute that chain, right? So let's take a look at the generic structure. So basically, you can think of now as a tree of chain because it branches off, and based on the nodes, you decide a path dynamically, right? So again, you have multiple inputs, single output. You have a router chain. Here we have an LLM router chain, but it could also be a similarity search-based router chain. In LLM router chains, we ask LLM that this is my product. What chain should be my next step, right? And basically, again, you have for an LLM router chain, you will have a template, router template. You will have LLM, you will have an output parser that parses the output. And then based on that parsed output, we would decide the next chain to be executed from one of the specific chains or the default chain. Right. How would you implement it? So basically, first you will create your default chains just like we saw before, right? And we'll see again in a while. And once you have done your default chains in specific chains, you will create a router chain. And in router chain, basically you have a router template specifically designed for this task. We'll look at the router template in a while. And once you have that router chain, you create a multi-prompt chain. You use the router chain, the destination chain, and the default chains for that multi-prompt chain. And once you have the chain ready, you run it and you get your output. That remains same, right? So now, before moving on the further topic, let's see a small demo. Yeah, let's see a small demo that about this chains, right? So we are not going to go through the setup right now, but this notebook will be shared with you, so you can have a look at the nitty-gritties and the detail. But basically, first we create a name generator chain, like a simple chain that we talked about before. Then we create a tagline generator chain, and we combined it into a sequential chain, and that sequential chain generates both the thing. And then we leveled up our tagline generator using a multi-prompt chain, right? So for that, as I said, first we'll create a default chain. The default chain template, you will notice that does not cater to any specific audience, right? It just says you are a copywriter that writes taglines. It does not say for whom, right? And you create a chain out of it, and then you create a specific chains. And for here, you will see the difference in the templates. The first one says you are a copywriter that writes taglines for customers in their teams. And the second one says you are a copywriter that writes tagline for customer in their late 30s, right? So that's the difference. Of course, this is a very minor difference, but depending on your task, it could also be much bigger of a difference, right? Once you have your individual chains ready, you put it into a dictionary, and using those individual chains and everything. Oh yeah, before that, you'll create a router chain. So I told you we'll look at the router template, right? So this template basically says that these are the destinations, right? That teams and middles are two destinations, and the inputs that these destinations take are company, product name, and product description, right? And what you are supposed to do is decide the destination and decide what input should go there, as given to you, right? And then once you have this router template, you create a router chain, and this router chain will be used to create the multi-prompt chain using the destination chain and the default chain. Now, how it decides on which destination chain? With each destination chain, there is a description attached, right? What this chain is supposed to be for. And using this description, the router chain decides which chain to use. Okay. Once we have created our multi-prompt chain, we again recreate our sequential chain with our new updated tagline generator, right? And the old name generator, same as before. And this new sequential chain is our final product, and we'll see it in action now. So one thing LangChain offers is debugging. So LangChain.debug, if you set it to true before running anything, it will give you a much detailed, richer output that you could use to understand what's happening inside your chain, right? And we'll use that today. So basically, once my full chain is ready, I'll query it with the inputs, that is the company and the product description. And what we'll see is first it entered the first chain, that is the name generator chain, and it generated a name, right? And once that is done, the next step is executed, that is the tagline generator. And in the tagline generator, so tagline generator is a multi-prompt chain, right? In that, the first step is the router chain, and that is executed. And the router chain decided that the destination chain should be a teens chain, right? And this should be the inputs to the teens chain. And once it does that, it will execute the teen chain and it will generate, so it will generate based on this prompt, it will generate your tagline, Audio Mechanics M1000 over your headphones, turn your world up to 11. Right. Now let's think of an example that is actually more towards, caters more to a middle-aged audience, right? For example, an anti-aging cream, right? In that case, so the product description goes like a luxurious anti-aging cream that reduces the appearance of wrinkle and blah blah blah, right? In that case, let's directly jump onto the multi-prompt chain, and what you would see is the destination selected is middle-aged, and the input, of course, remains the same: company, product name, and product description that will be passed on to the next chain. And once it does that, the middle-aged chain is executed, right? You can see that from the prompt that is the middle-aged chain. You are a copywriter that writes tagline for customers in their 30s, and it does that and it generates tagline: anti-age youthful radiance cream, reverse the sign of aging and reveal your youthful glow. You could notice it's much less popular, much less imaginative, maybe. And now let's lastly take one example that actually caters to all the demographics, a generic one, right? Something like a luggage scale, portable luggage scale, that is designed by a travel comfort company, and it is used for frequent work travels, right? Now, teens could also use this. Everybody has luggage when they travel, and everybody can scale it, right? In that case, what you would see is, yeah, what you would see is the chain decided was null. Basically, the code word for default. And in that case, it will go to the default chain. You can see over here, you are a copywriter that writes tagline, right? The audience is unmentioned. It selected the default chain, executed that, and we have our tagline: the perfect way to keep your luggage weight under control, right? And yeah, so that is how chains go. And from this explanation, I hope you can see that since it gives you this foundational structure, you can pretty much design any workflow you want, and the only limitation would be your creativity over here. Okay. Any questions so far? In the chat. Okay. Let's move on then. All right. So every time designing a whole workflow from scratch is kind of tedious, takes a lot of time, right? How can we do better here? One of the things that LangChain offers is agents. The core idea of agents is, instead of deciding the workflow yourself, you use LLMs to plan those workflows for you, right? Apart from that, you can also give the LLM ability to take action, not just decide on what to do, but actually do it, right? For example, you can give LLM the ability to search Google, for example, right? So it can not only decide that I want to search Google, I want to search this on Google, but it can actually do it itself, right? So you can give tools like that. There could be a tool to manipulate a pandas data frame. There could be a calculator tool that the agent can use to calculate, right? And so with this agents and tools concepts, it becomes much easier because you don't have to decide the steps yourself, you don't have to design the steps yourself, and agents will do it for you, right? And of course, agents can interact with memories as well. Now we'll also see a quick demo of agents, right? Right. So here we are, the tool we are going to give the agent is the ability to search Google, and we are going to use something called SERP API for that. You could generate a key at the URL mentioned above, and basically we'll load the tool, right? So LangChain has a lot of integration capabilities. So it already has an integration or an adapter written for SERP API. But again, you can also write your custom one if you can't find it in LangChain already, right? Once you load the tool, right, you will initialize your agent. Again, you will give the tools, the LLM, the kind of agent that you want to, which we will not go into detail today, right? And then once you have your agent, you ask it a question, for example, which is the best engineering college in Singapore. And what agent does is, instead of just directly answering, it actually decides that, okay, I need to use my search tool and I need to input the phrase best engineering college in Singapore, search it, get the response from Google, right? And that is what this observed. It came up with 3 names from the Google search: National University of Singapore, Nanyang Technical University, and Singapore Management University. And based on that, it decided that now I know the final answer, and it's going to be National University of Singapore. Maybe this wasn't the right question to ask over here, but now with agents, this was just one iteration, but it could also be multiple iterations where it is not able to decide final answer just based on one action. It could also go through multiple iterations that I want to do this. Okay, now I want to do this. Okay, now I want to do this. And after multiple iterations, it could derive your final answer. But the idea here is LLM decided on its own what to do. You did not code anything, right? This is a much simpler example, but as the example gets complex, that advantage becomes more and more clear. Okay. Lastly, the question that arises when you learn about agents is, if you have agents, why are we learning about chains in the first place, right? If agents can do all this, you never need to code anything, right? Well, that's not the case. Agents do come with a downfall, and that is because you use LLMs to plan and to execute and everything. You cannot always think of agent as a reliable solution, because it could you could give it the steps to follow, but it's still not guaranteed that it will follow it, right? It will still skip steps sometimes, take different steps sometimes, right? You cannot guarantee anything there. And this becomes more and more significant when you are trying to design a product in a high risk ecosystem. For example, in healthcare, let's say you are creating a tool or a product that takes in patient histories, right? Your family history, allergies, any previous issues that a patient might have faced, and based on that, recommends some kind of solution or medicine to the patient, right? Now, you can tell it to always ask for the allergies and always cross-check the recommendations with the allergies, but it is not guaranteed that it will follow it. And if it does skip that, right, it could lead to a fatal error. A similar example would be, let's say you are creating a bot that is supposed to scrape the web and figure out what are good investments, confirm it with the investor, and then invest, right? So you have told it that once you figure out what investment you want to make, confirm it with the investor once, and then only invest. But it could still skip that step, right? You have told it, but it's not guaranteed to follow. In that case, again, it could lead to major financial loss. So in such high risk environments, if you have a chain workflow instead of an agent workflow, what that does is, because chain is a concrete workflow, right? It has to execute the steps you have coded in the chain. It cannot skip any steps. It cannot take an alternate path. So when you want it to constrain in that way, in that case, it's a chain workflow is the way to go, and that becomes much more clear in Iris ecosystems. So with that, I guess we have covered all the foundational modules of LangChain, and we will take a break about 5 minutes, 10 minutes. Yeah, Subrat, yeah, so we can take a 5-10 minutes break. we are here. So if you want to stay and ask questions, you can, or you can walk around a bit, relax a bit. And then once we return, we will look at a complete use case of LangChain that is a very general use case. Yeah. Yeah, super. Handing over to you.
Someone kick you out?
Yeah.
The what?
So there is one question in the chat window, if you can answer.
Yeah. So the question I'm going to repeat for everybody: whether chains provide some privacy guarantees.
So the language models by themselves, that's where our input goes to, and they return a response. So if you want, supposing your use case is that you want to limit the answers to your own private data set, and you don't want the model to access it during training. So what you can do is essentially the use case that will go through after this, that you create embeddings of your data set and then you try to answer questions off of it instead of providing your data for training. So in that way, it provides privacy, uh, that it is not having access to your data set. But yeah, apart from that, it does not access your private data unless the conditions are specifically mentioned by the service provider that they'll be using the prompts that you provide for any of their internal use, which I don't think most of the LLMs are doing.
And coming to whether chains provide any additional privacy concerns, I don't think so.
Chains, yeah, so LangChain by itself is an open source library, so it is not recording anything, or so there is no additional uh, processing happening on your data going anywhere apart from the LLMs to which the query goes. Hope that answers your question.
Does anybody have any other question? So the model, most models run on the cloud. They are too heavy to run locally, but there are models that could be run locally and with LangChain as well. Even if it's your own model that you have developed yourself, you can write a wrapper around it and you can integrate that model into LangChain. So basically an adapter kind of thing. And basically it would be able to use that local model. Have LangChain considered the cost? So there are, when it writes the adapter, there are ways to count the tokens, first thing, for your input. And most of these LLMs, the pricing structure is based on the tokens used. So it does give you a way to calculate cost, right? You cannot just do it based on the words. Tokens are quite similar to words, but somewhat different. and with costing that would matter. And in terms of optimizing cost, so as we said, we talked about summarization memory and everything, right? And when we talk about RAG, there are also multiple ways to decrease the number of token usage, right? There are techniques to do that, and LangChain does offer some of them. Yeah, I hope that answers the question. You could. The only restrictions you would face, so we have tried to work on something similar. The only restrictions you will face is parsing the web page, first of all, because they have different structures, and second is the paywall. So as long as you can automate that and actually give a good tool to download the PDF, Google search, searching the research paper is pretty easy. Sir, I think has a Scholar, Google Scholar integration directly, which if you use it would be even easier. So you could search for research paper that way, and not only that, but one of the techniques that has coming up is instead of using the title to search, you ask LLM to first generate an abstract, right, based on how it would go, and then search using that abstract, and that sometimes gives better results as well. But yeah, as I say, the downloading part, you would need some kind of some work there, because there are various ways to paywall it. So yeah, you need to bypass that. And yeah, once you do that, you could. And organizing it in a folder, again, you could create a simple Python function and pass it as a tool to LLM. And that function basically, let's say, takes in a folder structure and applies that folder structure, and LLM is supposed to decide the folder structure given the files. So you could create Python function tools as well. So yeah, I hope that answers the question.
So we recently participated in a hackathon in which one of the entries was doing something quite similar to this. So check out their work.
Yeah, so when the sources are not behind any kind of paywalls, there would be some ways to get these things done. And I guess there are integrations in LangChain with Archive and PubMed as well. So those tools and integration could also be used directly.
For example, if I really conceal the privacy, I want to process privacy information locally, but I cannot run my tasks because of the hybrid cloud infra. What kind of technical challenges for current LangChain as a technical LangChain?
A lot of people are working on trying to build low resource versions of the large models, and that their main goal is to just being able to run inference on instances with limited compute. And the main difference there is if the model is smaller, the quality would match the of course the very large scale models. So the output generation quality won't match, and the technical challenge there is even once you set up the inference, so we did try to run some inferences with maybe single GPU machine and ELS, but there, even though it did run, the output speed was quite slow, so it is only able to generate few tokens per second or minute, so which would be the limiting thing about such a product. But if you are maybe running it offline and the inference speed does not matter, maybe you could do such a setup and run. So any maybe GCP or AWS, any of the cloud providers would work in such a case.
And LangChain specifically does not have anything catering to this yet. I'm not sure if it's in the technical roadmap for LangChain or not, but
Yeah.
right now it does not have anything specifically catering to this.
So if you want to just run models which can run locally, it does have access to all the Hugging Face models. So there is an integration with that as well. So you can use such models along with LangChain, but I don't think LangChain does add anything in terms of the inference speed or the privacy. I guess we can continue with the session.
Yeah, you guys can continue with the presentation because we have a Q&A session at the end. So
Yeah, exactly.
Okay.
Can you change? Okay.
Screen share.
Okay. So until now, we have seen how powerful language models are when working with text data. But one limitation is that their knowledge is limited by the training data. And when we are building applications, we can run into the following issues. So, training language models is a very expensive process, and due to this, in most cases, the training data for any of the service providers would be out of date, and we will miss out on knowledge of latest events and trends. Another problem is that if we are asking LLM about something it does not know, what it does it tries to extrapolate some things from things which are similar to the questions we ask, and it will basically give us an answer which is factually incorrect. So that might be another problem that we can run into, and the third thing is a same concept can be used in different types of domains. So if our prompt is not descriptive enough, the answer that the LLM provides will not be the same as what we have expected. So for the example on the top here, I basically asked what is RAG to ChatGPT, and as its training is limited to 2021 or the start of 2022, it will not have information about retrieval augmented generation, and so it does return the meaning of RAG in other domains like project management or biology, but it does not return the answer that we wanted. So how can we overcome this? So what we can do is provide a bunch of text that is relevant to the thing that we wanted. So here what I did was I basically copied a blog of about RAG, pasted it into the context part, and then again asked the question. And in the lower half, we can see that when we provide external context with the knowledge that we want to use, LLM are able to generate insights out of it. So providing this context helps us in many things. It will help us to prevent hallucinations. In most of the cases, we can ground our answers from the knowledge that we have provided. And let's say if you were building some applications, in most scenarios, a client would want to generate some insight out of their company documents, and those documents would not be accessible on the web, and directly using LLMs would not be possible in that case. So we could use the knowledge present in those documents and combine it with RAG to cater to such a use case. So how RAG basically works is there is an ingestion phase where we basically pre-process the data that we have. So let's say there are some company documents and we want to derive some insights out of it. So once we get the documents, we load the text content out of such documents. And so when we load the text documents, it would be page-wise or the document-wise, but we break the entire text document into smaller chunks. So we do this just to ensure that one chunk has information about one thing only, and it does not have information about a lot of different things, because it would just add noise when we are trying to generate insights. Once we have the splits of smaller text data, we pass them through a paragraph embedding model, generate embeddings out of it, and stored it into a vector stored. The vector stored would help us in finding the relevant paragraphs when given a question. So this is the pre-processing step that we need to follow. And then when the user asks a question, what LangChain would do is retrieve the most relevant paragraphs using the vector store. It will combine the text from this relevant paragraphs and combine it with the user's question, put it into a prompt, and get a response from the language model. And the answer that the language model generates is basically sent back to the user. So just an example of the process that I just mentioned. So what I did was I basically loaded the LangChain documentation about extracting different types of extracting data from different type of documents. And I basically asked how can we load CSV data in LangChain. Let's say it had the following embedding, and the data that I loaded from the LangChain documentation mentioned loading text data from different sources. So all of this had the following embedding, and let's assume that we are able to correctly find the CSV data, because both our question and the context in the CSV document will have some overlaps, and we will get a high similarity score there. We then use the text content from that document and pass it into a prompt, and that would basically help us answer the question, which was not initially present in the knowledge base of the language model. So let's see this in action. We install all the dependency. We create classes for the text model and the embedding models. Then for the ingestion phase, so here basically I am using a document that has some financial information about Google's its income and expenses for the year 2022 and 2023. And we will try to derive some insights out of this document. So we provide the path of this PDF, load all the text content. We split those into smaller chunks of 512 characters, and then we embed them and store into a vector store. So doing all these things is just a single line of code, and we can just basically explore how the vector store basically saves all the data. So uh, all the smaller chunks that we had created, those would basically have an embedding. It will have some information about where this particular paragraph came from. So the document name from which the paragraph was taken and the page number. So this is basically the schema that vector store uses to store our smaller paragraphs. And then the user asks a question about what was Google's total income from operations in the year 2022. As we saw in the slide, we first retrieve all the relevant documents, we combine it into a prompt, and then we get the final answer. So we are here able to answer that Google's total income from operation in 2022 was $20,494, and we are able to find this information from a document which the language model did not have access to. Let's also check the selected documents that the vector store gave us. So here we can see that this is a small paragraph that we had broken down into, and this basically has the information about the total income from operations in the year 2022. And the language model is able to infer from this text basically, and we are able to get the final answer. So this was the most simplest of RAG implementation that we could perform. There are ways in we could improve our performance with RAG. So there are strategies on how we could split the data better, how can we retrieve the most relevant data, and there are some post-processing strategies after retrieval as well. So we will take a brief look into these techniques as well. So the strategy that we used in the demo here was based on a fixed limit on the number of characters. So just to mimic the same strategy, let's say we had some data and we are splitting it based on the number of characters. So here I am splitting the entire text into smaller chunks on every 3 lines. So in this example, we can see that there are context breaks in between this paragraph, and another approach could be that So we extracted this text data from a web page, and the web page would basically have the heading and the paragraph tags. So what we could have done was use those information and break the chunks based on the headings of the tags. So the example on the right does that thing that it breaks the entire text on the basis of the HTML tags, and we can see that the chunks there are more contextually coherent, and each chunk is about one particular thing only, and there are no contextual overlap between two chunks as well. So there are such splitting strategies in LangChain. We could split based on HTML tags. If we have some code, we can also break them using the information present in the code. So we could basically break the text of the code using the functions or the class and the blocks between them. There are also strategies to break the text data based on markdown headings as well. And what this strategy ensure is that the information to noise ratio in each splitted chunk remains high. So once we have good chunks, there are strategies to improve the retrieval part as well. So as I mentioned, if our prompt is not descriptive enough, uh, we might not able to correctly capture the intent of what we wanted to ask. And in that case, when we are trying to find the relevant documents for that particular question, we can miss out of on some important information. So there are ways to improve this part as well. So in this particular technique, what we do is we take in the query, we pass it to the language model, and we ask it to generate different versions of the same query. And with each of these query, we retrieve the top key documents, and using a combination of these things, we basically find the things that are most relevant to us and pass it into the prompt. So using multiple versions of the same query improves our chance of finding the relevant documents. There are other strategies on how we could improve our retrieval process as well in LangChain. Uh, so this is one strategy that we can adopt after we have retrieved the relevant documents. So let's say that our splits were not very good, and we had retrieved a relevant document, but it also had some other information. So here we still want to load the CSV data, but the documentation did have some extra information about what basically a CSV file is, which we would not want in our answer. So LangChain has this particular strategy where what we could do is once we have retrieved the relevant documents using the vector store, we could again pass them to an LLM and check what parts of the retrieved documents are more relevant to us, and we then only pass in the relevant chunks to the prompt. So this could help us um, pass more relevant information, cancel out the noise present in the retrieved documents, and improve our RLG process overall. Let's also see this in action. So In this case, we could see that along with the information that we wanted, there are a lot of other stuff also present in this documents. So let's use the contextual compression method provided by LangChain. So we use the same vector store to retrieve the documents, but we additionally pass in the compressor, and that would use the LLM to remove all the noise data present in our documents. And we can see that after passing all our documents through the LLMs, only the relevant parts from each of the documents are present, and this can and we can see how this can help us improve the R&D process. So this slide basically has a list of different techniques and pointers to the description of these techniques in the LangChain document. Uh, we will not be covering each of this. We just show some of this in action, but you guys can look into other techniques in detail as well. Yeah. So that's basically from our side. Uh, you can access all the content used in the presentation from this GitHub repo. It will have all the collabs and the PDF used here as well.
Put the link in the chat.
Yeah, so we are open for any questions that you might have.
Before people start dropping off, if we could see all of you once, people don't mind sharing or turning on the video.
Yeah, thank you, Infocusp team, for this nice presentation. It was quite interesting. Like, so now we can take questions. If anyone has any question, they can unmute themselves and ask, or they can post it on chat.
So just to give a bit more context, so both Jeet and Vinay have been working on a number of projects that actually involve using these LLMs. So basically, we were using the Palm API in actual projects where the task was similar to what you just described. So retrieving information from a set of documents, and in another case, trying to build a data processing and filtering sort of pipeline using the tools available in LangChain. So yeah, they have good experience of working with this library and using the APIs as well.
I'll ask a silly question. So, what is the current trend in the industry regarding LLM? Like, we see a lot of stuff going on, like after ChatGPT. So, can you please share your experience? What's going on in the industry, not in the academia side?
We were actually going to include one of the slides, but let me mention the points nevertheless. So one good direction in which there's a lot of people working is basically what we talked about, running inference in low resource environments. So a lot of people are putting in effort so that these inferences can be run on common laptops or at least ones with GPU. And other is there's a technique called so basically for fine tuning and uh, not having a full size models, there are techniques which can generate adapter weights, essentially small additional weights to the large language model, which are much smaller in size compared to the original model, but which can still be helpful for fine tuning the models for your particular task. So there's a library. So these techniques are called parameter efficient fine tuning, and there's a library by Hugging Face called which has many of these methods implemented. That's also something people are working on. In LLMs per se, their prompting isn't purely a science, so it is more of a property of what people discover while trying out different things. So there also, if people find certain prompts working best for particular use cases, then they either publish papers or blogs on the subject. And those come in handy even when building applications around it. But in the industry, the next thing people are working on would be how to build a proper secure workflow for applications which make use of such language models so as to prevent people from using it for any other purposes than for which it was implemented. So supposing you build an application and then someone using that application keeps recursively querying it for their own use case, then you want to prevent such a thing. So there is also, at least in the industry, people are also looking into that aspect, that you prevent such occurrences and you build a secure workflow around whatever app that you launch publicly. And of course, there are practical things also that you need to take care of, like there's a rate limit of how many tokens you can pass on to the model per second and how many so the response is that it can serve continuously. So when running inference in batches, you also need to take into consideration those things, which are for now also a limitation.
I see. Okay. Thank you for the answer. Anyone has any other questions?
If not, maybe we can ask you questions.
Yeah, there will be a quiz session after the seminar.
Thanks
Okay,
again, Subra, for the invitation, and yeah, thank you all for listening. And yeah, your time.
Yeah. Thank you, Infocusp team, Palakjit and Vinay, for this interesting talk. I think we should end here. I don't see any questions. Thank you, everyone, for joining for this seminar. Okay, we'll look forward for the next seminar.
Thanks.
Okay. Thank you.
Bye.